Right, hello. We've got a brilliant 90 minutes ahead of us. I think first up, we've got Vicky Neale, and I believe she's going to talk about some maths, as many people are. Hello, Vicky.
Hi, James. This is exciting, isn't it?
I know, it's really exciting. Do you want me to introduce you, or do you want to introduce yourself?
Either's good with me. What do you prefer?
I can introduce you.
Go
I've
for
got
it.
some notes here that I think you've written. It says here you're a maths lecturer at the University of Oxford, and you like sharing your enthusiasm about maths with people. I think we all like that. We all like maths here. You've got a new book, I believe.
I have, yeah. It's called Why Study Mathematics, and it was published on Tuesday. So I'm super excited. Can I wave you a copy?
Of
I've got
course.
one here. Look, I'll show you. There you go. Why Study Mathematics?
Polar bear.
It's got a polar bear. What's not to like? It's got maths and a
That's
polar
lovely.
bear.
Yeah, maths and polar bears. Maths and animals is always a good thing. And what else have we got here? You like exploring maths and knitting and using knitting and crochet. I presume they're
Yeah.
not
These things are
mutually
combined.
exclusive. Oh, yes. And yeah, I think that's all I've got about you. Anything else that we should know before we start getting into the maths?
No, I think we should do maths.
Let's do some maths. So what have you got for us today then?
Well, I'm following on from Fran, and I'm in awe of Fran and her paper folding skills. So I feel a little bit nervous doing this, but I thought we could do some paper folding. So this is a do-it-yourself trick. So I'm hoping that everybody is going to join in. Are you up for this, James? Have you got a piece of paper there you can join in?
I've got, what do I need? I've got a piece of, if I
just
go
any kind of paper is good. So I'm just going to see whether I can start my...
I have some paper. You've got my visualizer, which has my messy desk, but we're going to have to put up with that, right?
Oh. So I'm hoping that you can see my piece of paper as well. I've got a nice
pile of paper here. I'm waiting for the stream to catch up, see if I need to move the camera, but carry on.
Yeah, so we've just got normal paper, A4 paper, whatever paper you've got handy. It's all good. And we're going to do one bit of drawing, and then we're going to do a lot of folding, okay? And the drawing is, I'm just going to put a point. It sort of doesn't matter. There's a lot of flexibility about where you put your point, but if you want yours to look like mine, then I've put it sort of towards the bottom of the page in the middle. I've got my paper arranged in landscape. So I guess it's just below the middle, somewhere there. So I've drawn mine nice and big, so hopefully you can see it on my camera okay.
Yeah, I think we've got two of us doing it, but
that's good. That's good. I'm hoping lots of us are doing this. I'm hoping lots of mathematicians around the world are busy going to fold paper with us together. So what you can do is grab the paper and fold it so that the bottom edge just kind of touches the dot that you've drawn and made it fold.
Yeah.
And there are lots of ways that we could do that. There are lots of possible ways that we could fold it up so that the bottom edge just kind of touches that dot and then make a nice crease there. And you can just sort of keep doing that. We can just chat amongst ourselves while we're folding this. We're just going to do this load. So the rule is always the bottom edge of the paper goes up to meet that dot and make a nice crease.
Brilliant.
And
while I've got you here doing stuff, I've got a couple of questions.
Yeah, go for it. I can hopefully fold and talk at the same time. We'll see. We'll test that out.
What's your favorite equation?
My favorite equation? Oh, I feel like that's asking me which of my two cats is my favorite. Yeah, I think they're all great.
If you had to choose one, what's kind of one you'd say, oh, I love that one?
Well, so I really love Fermat's little theorem, which is a particular result in modular arithmetic. So it's a really important result in number theory. It links up with group theory, with cryptography, with all sorts of things. And at the heart of that is a kind of equation. If I was being really precise, I might call it a congruence. And that says that if P is a prime number, then a to the power p minus 1 leaves a remainder 1 when you divide it by p, if a is not divisible by p. So that would be one of my desert island theorems, I think. So if I'm allowed to count that as an equation, then I think I'll count that one as a
I'd say it's equation/theorem, so I can go with that. I think that would probably be mine as well, to be fair. What's
your favorite equation, James?
I was going to say Fermat's little theorem as well, but that feels like a bit of a cop-out now. I'd probably say Riemann rearrangement theorem then, because that's what I did this morning.
Okay. Perfect. How are you getting on with your folding, James?
I'm done. I don't know if I'm like going really fast or I'm just
Was
not
yours a little
doing
bit like
everything.
mine?
I've got a quadrilateral.
Oh.
It's a 5-sided shape actually.
Oh, I
Is
think
it
we
one,
I think
two?
we might have been doing something different, James. I think you
Oh.
might be being sidetracked by Fermat's little theorem.
Oh,
Explain myself very
I
clearly.
get what I'm supposed to be doing now.
So I'm just always folding the same bottom edge up to the dot.
I went off and I get what I'm doing now. Okay, yeah, that's
You're freestyling it.
Yeah, I think I know where this is going.
So I was not quite sure whether the folds would show up really brilliantly on my phone camera. Actually, I think possibly the folds show up better on my camera than they do in real life. But I did one earlier. Shall I show you the one I did earlier? I did the folding, but then I drew lines on for the folds because I thought that might make them show up better. Is that showing up for you okay, James?
Yeah, I can see that. Yeah, I'm just now refolding because Ooh,
so I think this is magic because we just did folding, right? They're all straight lines, and then we've got a curve. How cool is that?
No, that's rather cool. I quite like that. Sorry,
is your curve appearing?
Yes, my curve is appearing. Yes, my curve is appearing. It's just I completely and utterly screwed up the instructions, and I was like, okay, I've got a 5-sided shape, and I'm like, okay, what are we going to do now? But yes, I know where this is going now. Oh, wait, yeah, I've got a curve-ish. It kind of goes like that. It's a rougher box. Oh, you can't even see that. That's amazing.
We're sort of close. There we go. Yeah.
There we are. It's like
mine.
It's like there. I've got a curve.
Yeah. So there's this curve. I guess officially all of these folds, these straight lines are kind of tangents to this curve if we're being really precise. And the jargon is kind of an envelope. And this curve is a parabola. And I guess parabolas are really important in maths. So I think it's really cool that just by folding straight lines, we can create a curve. I think that is my magic offering for you. And I thought I'd show you a few related things, if that's okay with you, because I've got some,
of course.
Others I
prepared
here earlier. So this is one way of creating a parabola using straight lines by doing this fold and always folding up the bottom edge to the dot. Another way of doing it is if I got some dots drawn down the side of the paper and across the bottom of the paper, and I can kind of join up dots, I can create a parabola, I can't speak now. I could create a parabola that way too. And this works really well if you stitch it. So here's one I stitched earlier. Can you see that? Should I hold it up?
Yeah, I can see that. That is good. Yeah, I can see that.
So I just put 2 parabolas together here, which makes this kind of rugby ball shape. And stitching is really great because the lines are really straight. It's even easier than using a ruler or something. You don't have to worry about straight lines. And then you can just have lots of fun putting these together in whatever creative ways you come up with.
How many of these have you made?
It's probably best not to ask that.
That's what I expect. Oh, because, I love that one.
Because one thing that I like to do is make Christmas cards this way. I know this is Halloween. I feel like I should have made Halloween cards, but I'm not sure whether Halloween cards are a thing. And Christmas cards definitely are a thing. So in terms of how many of these have I made, probably hundreds. Because these are parabolas again. If I hold that up a bit closer, you can see.
Yeah, we can see that.
Still parabolas, just, it's all a case of how can I put them together in a Christmassy design. So this is a tip for anybody wanting to plan their Christmas cards now. So the Christmas tree is one I got adventurous and I put beads on it as well. So yeah, all sorts of interesting things you can do with Christmas card designs. I did a snowflake.
I love it.
So I've got another one that I can show you. This one's a little bit more advanced, but I think we should be brave and give it a go.
I can hardly do that one.
A little bit harder to try at home, unless you happen to have a circle of dots to hand. So from my pile next to me on my kitchen table, I've got a nice circle of dots. And I very kindly made a nice PDF with some templates of these things, which is on my website. So if one of the behind the scenes people would very kindly pop a link. If anybody wants, there's a PDF with a few different templates. So you could just make your own in GeoGebra, which is how I made mine. But if you want a PDF, if you want to have a go at printing it off, you can. And this one, it can be helpful to think about the dots as being numbered. So I've just started numbering, and all the way around this circle, I've got 72 dots here. And and I've just numbered the first 20 or so. You don't need to number all of them. And the rule that I'm going to use here is that I'm going to join n to 2n all the way around.
Yeah.
Okay, so I'm going to find my unnumbered one. And I've got my nice ruler here. And let's give this a go. So I'm going to do 1 to 2 and 2 to 4 and 3 to 6 and 4 to 8. And at some point you realize that you don't really need to think about what numbers you're doing. What I'm kind of doing is moving one end of the ruler around 1 dot at a time and the other end of the ruler around 2 dots at a time, which makes it just a little bit quicker to see what's going on. On the other hand, I'm about to draw 72 of these things. How much patience do you have, James?
Pardon?
How much patience do you have?
Oh, we can just sit here and watch you draw lines for like 20 minutes. I'm fine with that. Yeah, I'm a mathematician. I have to have patience.
Experience? I do have one that I finished drawing earlier, so I could just do here's one I prepared earlier if you like. Can you see?
No, we're not Blue Peter.
To tell from the beginning, isn't it? It's not really looking very promising so far, I admit, but this is where the magic comes in, because we just have to kind of keep going. And it works better if you do this quite precisely, but if I do it quite precisely with a thin pen, then it's not going to show up on the camera. So that's why I'm using this nice fat pen. Hopefully that works out okay. You just keep going and it just looks a bit like a bunch of lines and you think, well, really? Let's just keep going.
I'm starting to see a curve there.
Yeah, you're starting to see something appearing there. There is a bit of a curve appearing, isn't there?
I'm seeing a curve. I don't know what it's going to be yet, but I can see a curve.
Tell you what, James, while I'm just kind of drawing some lines here, do you want to remind everybody what we're doing here, why we're here today?
Yes, that's probably a good idea. Hello, right. You're not going to be able to see me because you can watch Vicky having a good old draw of her lines, but we're here today to, we're running this event alongside a 24-hour comedy event done by, is it Matt Watson? Is it Mark Watson? I've forgotten his first name. His name, I can't find his name in the notes, but he's doing a 24-hour comedy show and he's raising money for some charities. I haven't got these up. You've put me on the spot here. Host and presented. There we go. So we're raising money, and I think if I turn my camera on, give me a second. The link is there. If you want to give money to the charities, I think one is for comedians that are struggling under the COVID-19 crisis, and there is another one for people financially struggling. And the link is in my up above there. Mark Watson, thank you, chat. Yes, Mark Watson, it's up there. Go to donate.watsonathon.com and you can donate money. It all goes to good causes, and we're doing this kind of thing in parallel to Mark Watson's 24-hour live stream, and he's on Twitch. We're here. Have we got a link to Mark Watson's stream? I think we have a look. No, but I think there's one at www.watsonathon.com.
Brilliant. Thank you, James. It's really great that we can do mathematics and help a good cause at the same time. I've gone wrong here because it's quite difficult to do this underneath my phone camera. So I'm going to sneak in one that I prepared.
Wow.
That was a great response, James.
That was quick.
Yeah, you were so busy concentrating on pointing people to the fundraising page that you didn't notice how quickly I drew this. How good is that?
Wow, that was so quick.
I think it would be so hard to predict that this was going to be the shape that would come up. I think the first time I saw this was a massive surprise, and it's still still a surprise. So this is a curve called the cardioid. Some people might know. And if anybody was, well, at least UK time, up super early at 5 o'clock this morning, you might have noticed there was a stitched cardioid in the background of Eliane's shot. So go find the YouTube stream from 5 o'clock this morning if you didn't see that, because it was really lovely. I've got some stitched ones as well. So here is a stitched version of my cardioid. And the good thing about stitching is that if you go wrong, you can just pull out the thread. Whereas if you're drawing it with pen, it's quite difficult to rub out one line. So stitching it works really well. And this was with the rule that we were joining N to 2N all the way round. And then I guess you can say, well, what if we joined N to 3N or N to 4N or something? And these are great questions. And here's some I stitched earlier. So you get this nephroid shape. I think this one's called an epicycloid of Cremona. Have you ever spotted any of these in real life, James? So
is this the link where you get me to bring out my coffee cup?
Well, it depends whether your lighting is there, but I noticed you had a coffee cup. So the spotlight in my kitchen, when I'm getting a glass of water at my kitchen sink, if I get the angle just right, at the bottom of the glass, I can see one of these kind of shapes appearing, because if you have the light reflecting off a circular surface, you can get these kind of curves appearing. James is now going to experiment with the lighting. It is a case of having just the right kind of light. So a spotlight works quite well, giving you a nice precise beam of light reflecting in. So you do spot these every now and then. It's worth keeping an eye open the next time you're filling up your wine glass or your coffee cup or whatever.
It's not going to work. Anyway, time.
I think it's kind of magic that you can draw straight lines to get a curve, don't you?
That is magic. I will allow that to be called magic.
Thank you, James. That's very nice of you.
I'm not the judge of this. Anything is magic. We can call whatever we want mathemagic. I think I quite like these curves because I remember I did these in primary school, and these were one of my first actual mathematical things I did. We did this in a class, and I thought it was art. And someone said to me, "No, that's maths, James." And I'm like, "I don't like maths." And I was like, "Oh, if this is maths, maybe I do like maths." And it was kind of one of the things that kind of portrayed me forward to where I am now.
I gather there was a request to show them slightly closer, so I'm doing my best to show my stitch ones slightly closer. Top tip, by the way, if you do want to make these as greetings cards, the secret to success is to use what's called double fold no aperture cards. So there's one fold here, and there is another fold, which means the third panel I can stick over the back, so that the kind of sellotapey mess you get when you stitch them, you can hide inside a perfect card.
That's lovely. I love them. They are amazing.
On the subject of things that you might not think look so mathematical but are, would you like a treat? Can I show you my treat, James?
I think someone wants to see the snowflake. But
a snowflake. Let's do a snowflake first. Yeah, I've got a snowflake.
I've got a couple of. I'm just keeping an eye on the chat, and there's
that's great.
Someone wants to see the back of the needlework as well.
Okay, you can test how neatly I've started and finished. There you go. So it's a good challenge as you're doing this as a mathematician to think, how little thread can I use on the back? How can I choose the order of my stitching to be efficient so that I don't use lots? So
what a lovely optimization problem.
Yeah, so the cardioid uses loads of thread on the front, but if you stitch it really carefully, there's very little on the back, apart from the ends where I start and finish and sellotape it down. Shall I show you some more of these close up while I've got them here?
People are loving this.
Oh, Christmas card.
We can just show them stitching, and they're just happy. People are pleased.
It's maths and crafts, James. What's not to like?
I know. I love that one. Is that a Rollo triangle in the middle?
So that's a good question. So a Rollo triangle, that's one of these shapes of constant width, isn't it? So
yeah.
Like a three-sided 50p coin or 20p coin or something. So I think this isn't a Rollo triangle, but it kind of looks a bit like it, because I think that the sides of a Rollo triangle are arcs of a circle.
Yes, they are. That's how you construct it, I believe.
And I think that these are parabolas.
Oh, yes, of course.
Getting into the jargon of different types of mathematical curves. So I think this is close, but I think this is not quite. Yeah, where are my other ones? Oh, yeah, this was another fun one earlier on. I don't know what this sort of curvy square thing in the middle is, but it's kind of a nice shape.
I'm sure you could derive some sort of formulas for it if you so wanted.
Right, so it's an interesting integration exercise or something to find the area of things for people who know about those kind of calculations. Can I show you my knitted scarves?
Of course, carry on. I think these were in my notes I've got, and I believe these are about distributions of primes. Or am I getting myself confused? I may be.
Well, let's see. So here is my scarf. And it just kind of keeps going in the way of scarves. It's finitely long, which is a bit of a disappointment, but let's just sort of pretend that it's infinitely long. I'll just try not to show you the other end on my camera. So the way this scarf works is I've got 6 columns. 1, 2, 3, 4, 5, 6. And each entry is either white with a blue border or blue with a white border. That's quite hard to say. And you kind of count along 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it kind of wraps round in each row. The rows are slightly diagonal. And as James just hinted, if you look really carefully, the ones that are blue with a white border are prime numbers, and the ones that are white with a blue border are not prime numbers. So here in 2 and 3, the only consecutive prime numbers. So 1 is not a prime number, just by definition. So a prime number, I would say, is a whole number bigger than 1 whose only factors are 1 in itself. So 2 is the only even prime, then 3, 5, 7, 11, and so on. And there's this whole nice little line of prime numbers here. 5, so we add 6 each time. So 5, 11, 17, 23, 29, and then 35 is not a prime. So that kind of breaks that pattern. But what I really like about this scarf is that it illustrates the rather cool fact that apart from 2 and 3, which are special cases, every prime in the world is 1 more than a multiple of 6. It's in this first column, or it's 1 less than a multiple of 6. It's in the 5th column. And
That's lovely.
Going down my infinitely long scarf, you see, that's where the primes are. The primes are never anywhere else. The prime number has to be 1 more than a multiple of 6 or 1 less than a multiple of 6. And
how long does that take you to knit or crochet?
This one's knitting. How long did it take? I don't really know, to be honest, because this is the kind of knitting that I can do in front of the TV or something. So it's just sort of peaceful evening activity. So I don't know, quite a lot of hours. But having made one, I thought, well, 1 is not enough. So I made another one.
Oh, this is amazing. I love it.
So that was my prime number scarf with 6 columns. And then I thought, well, what happens if I make a prime number scarf with 7 columns? So I made this one purple and white rather than blue and white.
Because we love generalizing as mathematicians.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on. So here are 2 and 3 again. This is how I know which end of the scarf is which, because 2 and 3 are a really good identifying feature to look out for. But look how different the pattern is this time. So with the 6 scarf, apart from 2 and 3, they were all 1 more than a multiple of 6 or 1 less than a multiple of 6. But look, there are prime numbers, purple with a white border, kind of all over the place. I mean, kind of all over the place in some carefully described mathematical way, except in the 7 column, right? Because their multiples are 7. And I guess 7 is the only prime multiple of 7. So it just kind of keeps going all over the place. Do you see diagonals in here, James?
Yes, I was about to say that there's diagonals. I quite like the fact that there's diagonals there.
Yeah, and those diagonals are somehow the same lines that were on the 6 scarf, because there's a kind of gap of 6 between these. So this is sort of the primes that are 1 less than a multiple of 6 and 1 more than a multiple of 6. They kind of show up. So yeah, there's lots of interesting mathematical questions that you can ask about the distribution of prime numbers on scarves. I haven't knitted any more scarves recently. These, well, not prime number scarves. These are my prime number scarves for the time being. But yeah, hopefully people like having a look at them. And somebody did ask me once for the pattern, because I wrote about these for the big internet math off a little while back. Some people,
I saw that.
The big internet math off, and somebody asked me for the pattern, and I found some software and made the pattern. So that's on my website. If anybody wants to make their own prime number scarf, you can find.
Do we have a link to that behind the scenes?
Let's hope our magic behind the scenes team can do something. I think we should do a shout out for the amazing behind the scenes people.
Yeah, I think they've been amazing.
On camera here. Some people are behind the scenes and also appearing on camera. Some people are keeping a low profile, but we can't do any of this without the behind the scenes people doing their magic. So massive thank you to them for setting this up and keeping it all running so smoothly.
Thank you to the behind the scenes. Well, you've got 3 at the moment. So thank you to everybody who isn't here at the moment, but is listening. You're doing a great job. Thank you, everybody. I'm sure everybody that's been given a trick, or everyone's kind of that's been comparing. I think that was the fancy word we were using. I think everyone would say thank you. They've put this all together, and it's been jolly good fun. I've really enjoyed today, and it's not over yet.
I'm just having a look to see whether there's any questions in the chat or anything. Have you been keeping an eye on this on YouTube?
Yeah, I've got 2 screens. This is why I've got a screen over here, which is doing the YouTube stream. And I've got this screen here that can see all. And then I've got a backup laptop over there. My tech setup is going a bit nuts at the moment.
It all sounds very complicated.
I've had too much time. I've been up since 5 a.m. this morning. And I've been like, what can I do? Tech setup. And so it's a bit all over the place.
Some of the other things since 5 a.m.
Yes, I have.
What have you been enjoying so far today?
All of it. There was a song this morning. We've had.
Chris Smith with the Proclaimers 500 Miles math song. That was amazing, wasn't it?
Yes, we had Bobby Seagull come and do some addition, I believe, or some sums. Then we had kind of other people coming along. I could mention them all. They've all been brilliant. It's been jolly good entertainment, and it's been kind of good all day. I think Lawrence had a good one. I was
very excited to meet Haggis's human. I've seen Haggis on Twitter. I hadn't met Haggis's human before, so that was a good moment.
So have I. Yeah, she compared for me this morning, so I was kind of like, you're the one who has the sheep on Twitter. Yes, this all makes sense now.
Fantastic. I'm just going to arrange my cards nicely under my camera here in case anybody wants to just catch those at the end.
Do you have anything else for us? Is that?
I think parabolas and cardioids and prime numbers is plenty to be going on with, if that's okay with you, James.
Yeah, that's fine. That's brilliant. I think we've got someone else coming along in a minute, so it's.
Yeah, I'm looking forward to seeing what else is coming up, and there are some big names coming up later on as well, aren't there?
Yes, we've got some big names coming up in this session. So everybody watching, you keep nicely in your seats, and you will get nicely entertained. So things are going to be good over the next couple of hours. So. Yeah,
I think I'm just going to sit tight till 9 o'clock, see what else comes up, see whether anybody else has a stitched cardioid in the background.
Yes, that sounds amazing. I love those cards. I'm going to have to make some myself.
Yeah, I think you should, James. I think it would be good. You can make your Christmas cards this way.
I will. I was thinking I can use it with pen and paper. I've just decided go the whole hog. Why not? Let's just get a needle and thread out, and we can just sew ourselves some Christmas cards.
Yeah, perfect.
Brilliant. And who have we got next? Let's have a look who we've got next. I think we've got Simon Allen coming up next I think he's doing some maths. Everyone's doing maths. We all love a bit of maths.
Fantastic. And yeah, maybe if you've got a moment now, then we can encourage people to pop over and donate if they feel able to do so.
In the last couple of minutes, you got anything to plug?
Yes, I could remind you about my book.
Yes. Anything else you want to plug while we're here? We've got 2 minutes left.
I'm just going to focus on the book, if that's okay with you, James, because it's less than a week old, and I'm really very excited about it. So it's designed for students thinking about maths at university. So if you're thinking of doing a maths degree, or you know someone who's thinking of doing a maths degree, then please get yourself a mathematical polar bear. Lots of advice about how to choose your maths degree, what kind of careers you might do after a maths degree, what kind of topics you might do in your maths degree. So I'm really hoping that's going to be useful and inspiring for lots of potential maths undergraduates.
I'd say that would be useful for me if I was choosing my maths degree at the moment, but I'm already halfway through a maths degree. So.
You've already chosen, yes, but you might still be interested to think about options you might do later in your degree or careers after your degree.
I'll have to get myself a copy and have a read then.
Very good.
I won't complain about maths books. I am surrounded by maths books here. And, well, I've got a Klein bottle.
You've got a Klein bottle. That's very cool.
I've got a Klein bottle. I like differential geometry and geometry in general. I've got the mini one as well.
That is the smallest
bitty.
Klein bottle I have ever seen, James.
Itty bitty Klein bottle. I love it. It's tiny. Klein bottles are fun. All maths is fun. If you ask me, I'm a complete and utter nutter for maths. So,
well, I think you've got a good afternoon coming up in that case, James.
Oh, yes. All is good.
Well, thank you very much for having me on this afternoon. I've really enjoyed sharing some parabolas and cardioids with you.
Thank you very much, Vicky. Thank you for sharing all your maths with us. We were greatly happy to see all of the maths.
Okay, take care. Bye.
Thank you. Bye.